In this section, we're going to talk about concepts in securing a data warehouse in Microsoft Fabric. We'll also focus on dynamic data masking, row and column level security, and how to configure granular permissions with TSQL. Dynamic data masking limits sensitive data exposure by masking it to non-privileged users. It helps prevent unauthorized viewing of sensitive data by enabling administrators to specify how much sensitive data to reveal. With dynamic data masking, the data in the warehouse isn't changed. The data stays the same in the warehouse, but the data is masked when it's returned to users who query the table. The example on the right shows the credit card number field in a table that is having its data masked in real time using our dynamic data masking. Note that the results that the user can see on the laptop below is simply the last 4 digits of the credit card number, while the entire number is stored in the credit card number field. There are 4 masking functions available for various categories of sensitive data. The chart on this slide summarizes the 4 types of masks available in the Fabric warehouse. Dynamic data masking, which is set up at the column level, offers a number of masking options, including full masking with the default mask and partial masking capabilities with the email and custom text masks, along with a random mask function designed for numeric data. Please note the descriptions and use cases for each, along with the limitations noted. As an example, in the partial function, the prefix padding and suffix padding specify the number of characters to expose at the beginning and the end of the string, and the padding string parameter specifies the string to use for masking the remaining characters. In the random function, the low and high parameters specify the range of random numbers to generate. Now let's review the steps for making dynamic masking work. Number 1, configure a column in a table for one of the 4 types of data masks with the create table or alter table statements. Number 2, define a list of users that have access to the data and grant them the unmask permission on the table. Number 3, when those users query the data, they can see the data in the format specified in the column definition. And number 4, administrative users or roles can view data unmasked by default. At the bottom left of the slide, there are some TSQL examples of the syntax for altering a column in a table and adding a mask. Let's review those. There's an email mask applied to the email column and a random mask applied to the salary column. The user Kim2 at adventureworks.com is granted the unmasked permission on the table and will be able to see the data unmasked. All other non-administrative users will see the data in the email and employee columns masked. On the bottom right is the output of the different users querying the email and the salary columns in the employee table. Kim2 sees the data unmasked as shown in the top image. Other logins see the data masked as shown in the bottom image. Now let's discuss row-level security or RLS. It is a feature that allows you to control which users can access specific rows of data. The access restriction is based on the identity of the user executing a query, and if a user isn't permitted to see the rows, they are silently filtered out of the query results when the restricted user issues a query. There's no change to the data in the warehouse. So when would RLS need to be implemented? Some example use cases would be ensuring that workers can access only those data rows that are pertinent to their department, or customers can only see data relevant to their company, or a salesperson can only see orders they place. We saw on the last slide that RLS enables you to implement restrictions on table row access. For example, you can ensure that users can access only those table rows that are pertinent to their department. Or you can restrict a customer's data access to only the data relevant to his or her orders. Rows are filtered based on the execution context of the user issuing a query. RLS works by associating a function which has a security predicate with a table. The function is defined to return true or false based on certain conditions, and it is associated with the table using a security policy. To implement RLS, 3 steps must be followed. Number 1, first determine the roles and criteria for accessing data. Number 2, then create a predicate function to determine the criteria for enabling row access. Number 3, finally, create a security policy. The security policy binds the function to a table, and it calls the predicate function when a query is run on a table. It filters rows that are returned based on the criteria in the function. The T-SQL code on this slide will show an example of how row-level security is implemented. First, let's review the scenario for this example. Assume there's a sales table that contains sales rep names and the orders they have placed. When a sales rep queries the table to see their orders, they should only see rows associated with the orders they placed, not the orders placed by other reps. To enforce this scenario, row-level security is needed. A function and a security policy need to be created. The function identifies who is executing the query. The security policy binds the function to the sales table and invokes the function to filter rows returned from queries on the sales table. If the user executing a query has the same value as the sales rep in the row, it's being evaluated for filtering, the row is returned. If the user executing a query is not the same as the value in the sales rep column in a row, the row is not returned. Next, let's review how to create the function. A function is needed to evaluate who is querying the table. The function has what's called a security predicate. A predicate evaluates to 1 to true or 0 false. The security predicate in this example returns 1 or true when a row in the sales rep column is the same as the user executing the query. This function is called by the security policy. If the sales rep at sales rep name passed to this function as a parameter is the same user as the user executing the query with the username, returns 1 is true. Lastly, let's review how to create the security policy. The purpose of the security policy is to invoke and enforce the function each time a query is run on the sales table. The security policy has a filter predicate that silently filters the rows available to read operations. Select, update, and delete. Note that the security policy sales filter is using the function previously defined as our security predicate. Notice also the state is equal to on, so it's ready to go. Column level security lets you designate which user can access specific columns in a table. It's implemented by issuing a grant or deny statement on a table specifying a list of columns and the user or row that can or cannot read them. To make user management easier, assign permissions to roles instead of individual users. So how does it work? When a user has been granted read access to a table without column level security applied, and they run select asterisk for their query, all of the columns for each row of data are returned. But if column level security has been applied to a column in a table for a particular user or role, when the restricted user runs select asterisk on the table, they will get a permission denied error. They can, however, successfully run a select on the columns they have access to. Now let's look at an example. Consider a scenario where we have an orders table that has a credit card column. Let's assume we want to restrict Mary at Contoso.com's access to the credit card column. The first thing to do is to grant Mary at Contoso.com the ability to read data in the table using the statement grant select on orders to Mary at Contoso.com. If we had only issued this grant statement, Mary could read all of the data in the table. To restrict Mary's access to the credit card column, we need to issue the statement deny select on orders credit card to Mary at Contoso.com. Now, when Mary tries to access the credit card column in the orders table, she's now restricted. When Mary queries the orders table with the select asterisk or a query that includes the credit card number, she will get an error. The select permission was denied on the column credit card of the object orders, database sales, schema DBO. Users whose column level access has not been restricted will be able to see all the data and all the columns in each row when they run the select asterisk. Fabric controls data access using workspaces. Within a workspace, Fabric has items. Items refer to apps, lakehouses, warehouses, reports, and other things. We can assign permissions at the workspace and at the item level. The item permissions and the workspace roles that we can assign come with default permissions, but sometimes those permissions are not granular enough. They might allow more access than we want to give to a user. That's when we use T-SQL granular permissions to refine T-SQL permissions to the level that's required. We use standard T-SQL constructs when we need to assign more granular permissions than what we can give them right now for the workspace roles or permissions. For Fabric Warehouse, object level security can be managed using the grant, revoke, and deny T-SQL syntax, and users can be assigned to custom and built-in database roles. If you're familiar with relational databases and enterprise warehouses, you'll know that there are 4 fundamental permissions governing data manipulation language or DML operations. These permissions are select, insert, update, and delete, and are universally applicable across all database platforms. All of these permissions can be granted, revoked, or denied on tables and views. If a permission is granted using the grant statement, then the permission is given to the user or role referenced in the grant statement. Users can also be denied permission using the deny command. If a user is granted a permission and denied the same permission, the deny will always supersede the grant, and the user will be denied access to the specific object. In our code shown here, we are denying select on the parts table to the user or role that you'd like to add here. In the final statement, we're granting execute on the stored procedure update parts to the role or user that we'd like to have insert. Note that there are certain objects that you will need to grant execute to rather than a DML permission. Some of those objects include stored procedures and a scalar function. DML permissions are usually granted to tables or views, but granting DML permissions to tables is not a good idea security-wise. It's best to grant DML permissions like select to a view to give users access to the table rather than granting it directly to the table. To perform inserts, updates, and deletes, it's better to use a stored procedure that includes transaction logic and error handling for both security and performance. Now let's see how to secure a warehouse in Microsoft Fabric.
Now let's focus on how we can secure our data warehouse in Fabric. Now, you may recall that when you work with a workspace in Fabric, you do have the ability to do manage access, and you can use the roles that are built in. So that's an option for locking down the workspace. You may also remember that we have the ability to individually share both the workspace and the data warehouse, and you have a bunch of permissions you can work with. For more information on this section right here, there is a later video with Lab 16 that goes over it. But since we're talking about working with the data warehouse, I'm going to go into the data warehouse and talk about some of the things that you can do through T-SQL. So we can create queries, and I have a number of them that I've created here. One that shows data masking. So this is an excellent option, especially if you have sensitive fields that you'd like to block portions of it out. You have that ability to do dynamic data masking with it. And this is a sample of the type of table that you could create. Notice that we have data masking being done on the first name field with partial. We also have it on the phone number, and then we have it on the email. And then they're inserting records. And if we were to select from the customers table once we create it, what we'll notice is we can see everything because we created it, but others that do not have the unmask or the select permission together won't really be able to get into it. But if they have select, but they don't have the unmasked permission, then they're going to see the mask on it. Now, a lot of this information you can get a little bit more detail on here from dynamic masking. So this link here that is available in MS Learn can be very helpful. And if you scroll down a little bit in it, what you will discover is it breaks down what each function does, and it gives you examples of how to use it. So the result that you see with the default function is going to vary based on the type of data we're working with, whether it's string data or numeric data or date and time or binary. And it gives you examples throughout. So you can see there's a default mask, there's an email mask, there's a random mask, and then there's a custom string mask. And then also a date and time mask, as you can see. Now it tells you that the date and time mask is for SQL 2022 and later. So you can take a look at this. You can see the permissions that I was mentioning there, the unmasked permission. And so this is a really good resource to find out a little bit more about data masking. The other option we have inside the warehouse is you have the ability to do what's called row level security. And row level security gives us the ability to either allow people or disallow people to get into certain records. I might have one data set, multiple people want to get into it, but I only want them to see the data set that is pertinent to them. So off that one data set, I want them to only see for their region. I want them to only see for their group that they belong to. And row level security is a good way to do that. And you'll see here that to roll out row level security, what you need is you actually need a security predicate. And notice that is created through an inline table valued function here. So they have an inline table valued function that they're creating that is called security predicate. It has one variable on it where it picks up the sales rep name. And it only can evaluate to either true or false, 1 or 0. And if it's we get a 1, that means that the row is accessible, and then it's going to look to see whether or not the user that's logging in matches what we have in this case in our sales rep column. to let them execute that query, that yes, they have permission to actually read the data. But the security predicate works together with our security policy. And the security policy you can see created down below here. This security policy is called sales filter, and it's adding in a filter predicate. So it's pulling that predicate that we just made up above into this, but it's a filter predicate that we're going to add to the sales table, and we're turning it on. Now, if you want a little bit more information about row-level security in SQL, this is actually a really good link to use right here. And as I get in a little further to it, you're going to see that it requires a security policy, and it talks a little bit more about it. But we were focused on that filter predicate. There are two options you can choose when you set this up. It can be set up with a filter predicate, which is going to filter rows available for a read operation. And it gives you some of the examples there that you can use against it. And then there's also a block predicate, which will block write operations, and it shows you the ones that it works with. Now, what I like about this link here is it actually has a lot of information about setting up these predicates and giving you a little bit more about how they're going to act, the use cases on it, a little bit more on permissions and best practices. But what you will see at the very bottom, if I can get to that bottom part, is it gives you a full-on example. So you can run this example. You can create a user called manager without a login. It's showing you how to do this to set it up, create a table with a schema, add in your records, give permission. So they're granting select on it to the different people here, and then running the security predicate, creating that, creating the security policy, and then they have you test it. So you can see that this will be a nice little addition to what we're talking about here if you'd like to explore this further. The other option we have with our warehouse is we also have column level security. Now, in the example here, we have a table called orders. That table called orders has three fields: order ID, customer ID, and credit card. So what you want to note here is you can use your DCL commands, so the data control language commands. There are grant, deny, and revoke. So deny, we know what that means. Grant, we know what that means. But revoke, we're taking back whatever we gave you. So you can use DCL, deny, grant, or revoke. And then you can deny, grant, and revoke different things like select, insert, update, delete. What you select depends on the type of object. So for a table or view, we can use, select, insert, update, delete. And when we start talking about a stored procedure, we have to grant, deny, or revoke, and execute. So it depends on the object. You might have to look that up, but it does depend on the object. So I know you can grant, deny, and revoke, execute on a stored procedure, also on a scalar function. The other types of functions that are out there, that inline and multi-statement functions, those you can give select. And then, of course, if we're talking about a table or a view, those can work with select, insert, update, and delete. So you can decide, but select, insert, update, and delete, those are all considered data manipulation language or DML statements. So you can see here that we're giving a deny select on the orders table to just that one field, credit card. So what you can do is, this is used for column level security here. And what we're doing is we're just going to deny that one field's credit card, and we can put in who that user is. And then by that same token, we can grant select. And notice we're not granting it on all the fields. We're just granting it to order ID and customer ID. So when we do that, what happens is that even though the table has three fields, whoever we grant this to is only going to be able to see two of those fields. Another way to do this is, instead of putting it on the table, we could put it on the view, and the view could just show the two fields instead of the three. That's another way you can approach it. And then if you don't have permission to that third field, then you're not going to be able to see it. So a lot of ways to work with this. And then our last example here talks about more SQL granular permissions. So what other permissions you can grant? Well, again, as we mentioned, it depends on the object, and you can do a grant, deny, or revoke with DCL. And then you can go in and you can do a select, insert, update, and delete, usually with the functions, tables, and views. And then execute would be for a stored procedure, or execute would be for a scalar function. So again, it depends on the object, but there are a lot of permissions. We've mentioned grant, deny, and revoke DCL permissions, data control language permissions. We've mentioned select, insert, update, and delete, which fall under the DML or data manipulation language permissions. But there's also DDL permissions that we're not focusing on here. That's to be able to give people permission to make stuff. So the DDL would be data definition language, and it's for create, alter, and drop. So you have a lot of permissions out there. I'm just scratching the surface with these permissions, honestly, but I might blow your mind here. Under permissions, there are tons of permissions. So if you want to do a deeper dive into permissions, you can take a look at this link right here. Okay, so thank you for joining me in this section. I hope too that you got a lot out of it and that I can see you again in the next session.
Now it's time for our knowledge check. What is the primary advantage of dynamic data masking, or DDM? Answer: it limits data exposure by obscuring sensitive information in real time. Question 2. What is the purpose of the security predicate function in row-level security, or RLS? Answer: it determines whether a row is accessible to a user based on certain criteria. Question 3. What happens when a user is granted permission, then denied the same permission in the warehouse? Answer: the deny always supersedes the grant, and the user is denied access to the specific object. In this section, we defined what dynamic masking is, what it does, who can set it up, and some of the masking rules that can be used. We also looked at the T-SQL to add the mask and how to grant the unmasked permission. We took a look at row level security, what it does, how to implement it using T-SQL to create a predicate function and security policy. We then talked about column level security, what it is, how to set it up through T-SQL using DML statements. Lastly, we looked at DML granular permissions for the table, the view, and the stored procedure, as well as some best practices around them for security and performance. For more information on how to secure a Microsoft Fabric data warehouse, please see the link shown here.